Okay, well, welcome guys. This is Good to the Last Drop, Writing Robust Flask Applications. My name is Isaac Evans, and I'll give you a little bit of context. But before all that, feel free to ask questions in the chat. I'll answer them afterwards. I updated the video conference bingo card I have here for hand raised by accident, which I now know is something that can happen in the virtual world as well as in the real world. Not that easy. So to start off with, I'd like to give you a little bit of motivation. Why does a Flask app need to be robust in the first case? And my answer to this, sadly, is that crime is fun. And I know this because I actually used to work for the US government in a offensive security group, which if it was not part of the US government would be very, very illegal. So I hope I can bring a sort of unique perspective to when we think about like security and robustness, what are the things that actually matter? I've gotten to see it from the other end of the shell, so to speak. And it's not just me here. We actually have some of the team members. I would point them out if we were in person, but we've got some ex-Google, Facebook, NCC, people from security consultancies and research teams represented from all over Silicon Valley. And R2C's mission is basically figure out good ways to make security more automatic for developers. So we have some open source tools that we've released, more that we're working on open sourcing. And our business model is basically to provide commercial services for large companies on top of those free and open source tools. But the gist of the question that we're going to talk about tonight is, all right, you wrote app.py, great. Now you're running Python app.py and you're kind of curious, you're about to put this on the internet for a couple billion people to look at. How do you know if it's secure? So to answer this question, I'm going to take us through a couple different categories. So we're going to go through three major things tonight. We're going to start by just looking at the stack. So this application, even though we're talking about Flask apps, if you write Django or you use another web framework like Pylons, there's going to be a lot that's applicable to your web application as well. Understanding the stack is really crucial. But the second thing is we're going to build an ontology of vulnerabilities. So, if you're going to defend yourself, you need to know the possible ways by which you can be attacked. And we're going to see a couple different frameworks that people have used to put those together and actually look at a bunch of them for Flask applications. And then in the end, the good news, we're going to talk about tools that can automatically check for security and correctness bugs inside your application. So the first one is, all right, let's talk about understanding the stack. And the good news is you're using Python. So automatically, we're immune to a lot of attacks, especially the worst sort of attacks that have plagued programs written in other languages like C and C++. For instance, heap overflows, buffer overflows that lead to stack smashing, most kinds of memory disclosures like Heartbleed. If you heard about that, there's a great XKCD you can look up. It's going to be a little too small on your screen probably that explains it. But there are just a few caveats. The first one is that just because Python is a memory safe language doesn't mean you can have memory leaks or you can't have memory leaks. So, some of the frameworks that Dean was referencing earlier, the machine learning toolkits of the world, you can still leak massive amounts of memory and have denial of service bugs related to that. And the other thing is, if somebody comes to you and they're like, oh, no, we don't worry about any of these C bugs. Our application is written in pure Python. That's not necessarily true because when you import a Python module, it might actually have a whole bunch of sort of sharp edges in terms of C bindings underneath. A really interesting example of this is the fact that if you use numpy.empty, that can allocate uninitialized memory for you, which can actually, it is technically possible to have a Heartbleed-like bug implemented inside your Python application, depending on the third-party modules that you're using. When we think about the stack, I've got a sort of simplified representation with 5 layers here. So the first thing is you wrote app.py, that's your web server. And then we've got the built-ins. So like your Python batteries included, all the modules that ship with Python, as well as third-party libraries that you might have added. So that would include like Flask or Django. And then the third piece, when we talk about Python, Python is just a language, but you need a program to actually interpret app.py and execute the code in it. So for that, most of you are probably using, even if you don't know it, if you just installed Python from the default sources, an interpreter called CPython. And CPython has to interact with the C standard library. So the C standard library on Linux systems is called libc. On Alpine, it's called Muscle. On Windows, it's called CRT. And then below that, of course, is the operating system itself. Now, the good news for all these layers of the stack is that thinking about security in them is really somebody else's responsibility. But the bad news is you have to stay up to date to get the benefit of the work that these other people have been doing. So you might be surprised at how many vulnerabilities people have found inside just, for instance, CPython. I included a partial list over there on the right, but I think there are at least 2 or 3 that have been found just this year in 2020. So what are the specific recommendations? Stay up to date on every layer of the stack that we were talking about there. So I would highly recommend using a tool like pipenv or Poetry. Both of these are wrappers. Well, pipenv is a wrapper around virtual env. They make it really easy to update your third-party libraries. So if you're using pipenv, you can just say pipenv update. You don't have to manually go through your requirements.txt file. And then you also need to make sure that you keep track of the security releases for Python itself. So one easy way to do that is you can go right now to CPython on GitHub, and you can click watch releases and be notified anytime that there's a new release of the main Python interpreter. A third bit is that you can update your operating system base image. That's just a general best practice. And you may find yourself sort of overwhelmed by how many updates there are. So there are a couple services that you can use that will give you prioritization. I'm not affiliated with any of these folks, but GitHub has some built-in security alerts that you may have gotten spammed by, sneak.io, pyup.io. Both of these, or all 3 of these, give you basically some data on, hey, is this just a regular update or is this a security update that I should definitely keep track of and make sure to update for right away. So we talked about these kind of bottom 4 layers, but there is a part that is your responsibility, which is what we're going to spend the rest of the talk discussing. So app.py, as well as how you interact with those built-in libraries, whether that be Flask or Django or other things that you're importing, that's all on you. So second part of the talk, let's dig into the ontology of vulnerabilities. So if we were to think about all the possible ways in which your app.py could be vulnerable to an attacker, what do those look like? And fortunately for us, there's actually a lot of work that's already been done in this area. So the one that you'll see a lot of people reference is by the Open Web Application Security Project, which I'll refer to as OWASP, because that's quite a mouthful. They have a list called the top 10. And this is based on essentially how we've seen people get hacked. What are the main ways that people actually got hacked? Let's just write down that list. There's another one called MITRE CWE. So if you've heard of CVE, which is Common Vulnerability Enumeration, this is sort of the sister to that. CWE is Common Weaknesses Enumeration. And I'll give you just a little sense of my guiding philosophy because, with hundreds of vulnerability types, it's kind of easy to get overwhelmed. And what I would tell you is that a short wall is better than a tall gatehouse. So what I mean is it's more important to be consistent and do something consistently everywhere across your application. You make sure that you do this rather than having some very sophisticated security thing that you're throwing in at the last minute. And additionally, this is something that's generally true in security. Simple is better than complicated. And I think that meshes really well with the Zen of Python. We should try to keep things simple as possible for the developers. Oftentimes security people like to make things more complicated than they need to be. So even in this presentation, you can give me feedback on how well I'm doing at keeping things simple. So I mentioned that OWASP top 10. Here is the list. We're only going to have time to go over 5 of them this evening. And I will do my best to keep us to the original close time. But I've tried to pick 5 that may be a little less obvious or a little bit less well-known. I think everybody has a sense for, okay, this is what broken authentication is. This is what sensitive data exposure is. We're going to talk about injection, XXE, security misconfiguration, which is going to be very specific to Flask, as well as cross-site scripting and some insecure deserialization. So even under injection, there are actually many, many different kinds of injection. And I'm just going to walk you through the most basic example, which is SQL injection. So here we have a little snippet from a Flask app. It looks pretty straightforward. So we see we're reading something from the request object, then we're constructing a SQL query. We're putting the thing from the user in there. We're executing that query. I'll give you just a few seconds to look it over and try to identify what's the problem with this query. So if you know SQL injection, this is probably really obvious. If you've never heard of this, you're probably like, well, this looks totally fine. And what I'd like you to consider is what if the queue parameter from the user's browser looks like this, apostrophe space or space 1 equals 1. If that's true, what the database is going to see is select asterisk from some table or title like empty string or 1 equals 1. And that's going to evaluate to true. So it's suddenly, instead of returning only the row where title matches, it's going to return all rows. So obviously, it's kind of a bug, but if you're talking about something like the users table for your application, this can be really, really devastating, right? It can bypass all of your access control, dump passwords. And this is actually, it's at the top of the OAuth list for a reason. This is a really, really easy way to get hacked, and it happens all the time. And what's crazy to me about this is that, in my opinion, when you look at this code snippet, it looks so innocent. If you went to a tutorial online, they would tell you like, hey, yeah, do this. And it wouldn't be until like the end of the book where they're like, oh yeah, if you're doing production Python work, don't do that. So this is an example of a gotcha. We're gonna see a lot of gotchas tonight. And the real question is, what can we do when we're faced with these gotchas? So I have a bunch of recommendations, but you only have to pick one. So the first recommendation is don't use SQL, use an ORM, so an object relational mapper like SQL Alchemy. And when you're using an object relational mapper, you can basically just say user.get. And this is automatically going to do the right thing. You're not going to be vulnerable to SQL injection. You don't have to sanitize anything. That's the ideal solution. The second answer is, well, usually if you talk to security people, you might have heard this. They'll tell you, don't trust user input. You got to sanitize all the user input. To be honest, I don't think this is a great recommendation. And there are two reasons for that. The first one is the database that you're using has to perfectly match the sanitization function that you're using, right? So the parser in that database might be slightly different than the sanitization function. And even if you get it exactly right, let's imagine that a database admin goes and upgrades the database to a new version. And then suddenly, like it has a new feature that your sanitizer doesn't know how to strip the syntax for. You might think that this is a ridiculous idea, but I can tell you it happens all the time. It's very hard to get that exactly matched up. It's also very hard, this is the second reason, to remember to do it everywhere. And you might run into issues where you're suddenly like double quoting or double stripping things. You have to do this on every single flow from user data into the database. And if you've written a web application, there are going to be a lot. So the third thing, which is actually the solution that big companies like Google will do. Google actually has a compiler plugin that will check this for you when you commit code, is to maintain separation between code and data. So the ideal way to do that is with parameterized queries. And even though this might look the exact same as what we saw on the previous slide, it's actually different in a really important way. So the question mark there, you might think that this is just sort of a different syntax for string interpolation, and request query ID is going to be copied into where that question mark is. That's actually not true. The database is going to essentially get two separate packets. One packet is going to have the query string, and another packet is going to have the parameters that should be put into those query strings. So we're maintaining the separation between the code, the SQL query, and the data all the way to the database. That is something that is a kind of difficult to grok maybe principle at first, but if you can maintain that separation between the control plane and the data plane, it will prevent all sorts of injection attacks, not just SQL. And again, the sort of last recommendation here is automatically enforce one of these things. So if you can, and RTC actually has some tools that we'll talk about later that you can use to help make it easier for the developers not to make simple mistakes like SQL injection. So the second thing that we're going to talk about is the fourth from the OAuth list. This is XML external entity expansion. It might have been a while since you've looked at an XML file, or maybe you've been looking at too much. So I'll give you a second to take a look at this entry and try to identify what the problem is. Well, you may have looked at this and said, okay, well, the problem here is XML. Some languages can be read by humans, not by machines. Others can be read by machines, not by humans. And XML solves this problem by being readable to neither. You would probably be right. But XML has a kind of unusual feature, or just lightly documented, I guess, that not many people know about, which allows you to include an arbitrary file from the file system inside the document. And so this is called external entity expansion. What it means is if you are serving this XML file on your server, and the attacker, like you're reading the values that go into this XML file for from somewhere else. If the user has any control over that, they can suddenly cause it to send any file from the file system, like one that contains secrets, out to the web browser. So that's not great. And the sort of unfortunate thing is this comes directly from the Python documentation. There are 5 XML sort of parsing and manipulation libraries that are present in Python. In Python 2, 2 of the 5 were actually out of the box vulnerable to this external entity expansion. Fortunately, in Python 3, that's been fixed, but there are actually a whole bunch of other attacks that have to do more with denial of service. So grinding your server to a halt, even if it opens an XML file that seems to look tiny, which are by default vulnerable. So if you do any XML parsing, my recommendation would be, first off, maybe don't use XML. That's probably not an option. So the second thing I would say is, well, can you disable XXE support in your library? Unfortunately, as best I know for Python, there's not a way to disable that. So really your only option is to use a different library. And in fact, there's a library with a great name called diffused XML, which articulated all of these different attack vectors and is not vulnerable by default to all of them. And then again, this is going to be a consistent theme, but you want to use some tools to automatically check to make sure you're not using the vulnerable libraries. I'm putting this here mainly as a reference so that if you look at the presentation later, you can come back and specifically run those checks. So don't worry about it too much if you are trying to write down the commands. The slides will be posted. So the next issue from the OAuth list is security misconfiguration. So here's an example of a very basic Flask app. It has at least 2 problems. I'll give you a minute to kind of parse through the code. First issue is that the secret key for the app is a development key. So it's something that should never be run inside production because that's an easily guessable string. It's not a random string that was injected from the environment. But by far the most interesting and scary thing is actually app.debug equals true. This, in my opinion, if you want to nuke the security of your Flask app in one step, is by far the highest leverage thing you can do. And in fact, this one line of code is believed to be the way that Patreon got hacked in 2015. The reason is if you run the app in debug equals true mode, anybody who looks at a screen where there's an exception, like where your app has an internal error, is actually allowed to run arbitrary code inside the context of your application, which is really not obvious, just from the fact that you turned on debug mode. Now, if you're reading things carefully, it'll tell you all these warnings about don't do this in production, but people do it, which is pretty insane. So the scary thing here is that there's not actually a lot of good recommendations that we can do in an automated way. The best advice I can give you is you really need to read the documentation for your framework and pay attention to these note callouts. Like here's one example from the Python 3.7 docs because they have all these caveats about the security properties of things. And if an attacker is looking at your application and they understand more about your framework than you do, you're probably going to have a bad time. Now, obviously, we can't all be an expert on everything. So one thing that a lot of teams do is they'll set up a code owners file, which is a way to make sure that for this specific file name, we want this set of people to be tagged as a mandatory reviewer on pull requests. And you can use that to kind of distribute the expertise. So if you've got some people who really know Flask or Django well, they have to review the important chain sets. And there are some tools that we're going to talk about later that have kind of gone through the documentation and looked for these sharp edges and automated finding them as much as possible. So there's another example that we could cover under security misconfiguration, but in the interest of time, I'm just going to skip over it. As a teaser, it's the way that Netflix actually got hacked earlier this year, which is pretty sweet. I will leave that as an exercise to the reader. And I would be remiss if I didn't finish out with this last issue, which is one of the most terrifying ones, in my opinion, if you're writing a web application. So here again, a code snippet for Flask. This is now the template file. We've got app name and value being injected into this template. What if value looks like this? So for those who aren't super familiar with the world of JavaScript, this is lovely. We can actually, in the attributes to this HTML input element, specify arbitrary JavaScript. So instead of just alerting this to the user, we could send it off to our own server, and suddenly we've stolen all of the session information for the user. Not great. And in fact, if you look at the docs for Flask, by default, so like in this example back here, app name, totally safe, value, definitely not. And if we look at the documentation, it tells us, hey, another thing that's very important are unquoted attributes. But it's pretty non-obvious, in my opinion, hey, there's a lot of caveats to the protection that you get from a tool like Flask. So Gotcha. Again, it seems to pop up everywhere. So there's a bunch of recommendations here. The number one thing, honestly, is to use a framework which is just less vulnerable to XSS. My bias is towards React.js, just because I know some of the people who worked on that at Facebook. And one of their explicit design goals with the framework was actually to make it harder for XSS attacks to happen, because that was something that bit them so often at Facebook. Unfortunately, we don't have time to go over in detail the rest of these. Happy to take questions on them later. And the last bit that we'll talk about, the 8th on the OWASP list, is deserialization. So here's somebody using the Pickle module in Python to load in some user preferences and save them back out. And what's the problem here? Well, funnily enough, if your Pickle module looks like this, you're actually totally screwed. So if somebody can control what you are serializing and deserializing, like if you just took that data straight from the user in your web application, this is a Pickle, the contents of a Pickle file, which will actually open a reverse shell, and it'll be as if an attacker has SSH'd into your server. And you might be like, oh, this is crazy. Who could possibly do that? This is so common that there is actually a payload in Metasploit, which is a hacking framework, specifically for, you can see it, Python lib pickle.py. And this is a problem for many other formats. PyYAML, for instance, is not safe by default until a few versions ago when loading an untrusted object from the user. So we talked about OWASP top 10 for web apps. We looked at that list of 10. Many of you might not be using things like Jinja. You might just have an API in Flask or Django that like it takes JSON in and it dumps JSON out. And there's really, the front end is doing its own thing. OWASP actually has a new top 10 specifically for APIs. Turns out there's a whole set of other security issues that go into how to secure an application for APIs, which honestly we don't have time for. But I think right at this point, your takeaway is probably, man, using Flask and Django, it's just full of gotchas. There are all these sharp edges, and you might be kind of tempted to just throw in the towel when it comes to security. So I have good news. And the last bit of the presentation, we're going to talk a little bit about, hey, what are the tools that we can use to automate security? What are tools we can use to automate making these applications more robust? And in fact, there are a bunch of methods, but we're just going to zoom in on 2 of them. So secure by design languages and frameworks, and using some static analysis tools. So code that looks at other code. So we've talked about this a little bit, but just to summarize it, for a SQL injection, using a framework like SQL Alchemy, it's not foolproof, but it'll go a long way to getting rid of some of the most obvious things. If you can switch to a front-end framework like React for XSS, use diffused XML for things like XML vulnerabilities. There are some vulnerabilities that we didn't have time to talk about around cross-site request forgery that can be avoided if you use JWT for authentication from the client. And there are also some really cool security static analysis tools that are out there. So there's one called Bandit, which was originally developed at HP a while ago, DLint, which comes from Duo Security, Flake 8. It doesn't ship with so many security related things built in, but it has a lot of plugins. And then I'll make a shameless plug for R2C has a tool called Bento, which actually tries to package a couple of these tools together and tune their configuration. And it has about 100 checks that we've written for Flask and Django. Some of them, actually, one of the Django co-founders, Jacob Kaplan-Moss, has been helping us develop. And then, of course, there are also some great tools that are proprietary and closed source if your company is looking to pay for them. SonarPython, Coverity, Fortify, Veracode checkmarks are all very common in the security world. And just to give you a sense of, okay, well, who uses these tools? We have a giant analysis platform at R2C that we can use to run code analysis over everything on PyPI. So this is a look at the sort of most popular things on PyPI. What tools do they seem to use by default? And actually, one of the things that I was surprised by was that Flake 8 is way more popular than even tools like Pylint. One caveat with this is if you're trying to use this out of the box, you may have quite noisy results for some of the tools. So here is a histogram that shows all of the checks in that Bandit tool run over the top 300,000 Python packages. So your average package is going to have about 100 results. And having looked at a lot of them, most of them are not things that you should be concerned about necessarily. So in conclusion, I think the real takeaways, if you're trying to think for the first time about, hey, how do I know whether Python app.py, when I put it on the internet, is secure? Stay up to date on dependencies, read the docs for your framework, and try to use something to check your code either manually or automatically.